Alright, this is an involved word problem here where we're going to do some linear equations to set up this situation so it can be maximized. Alright, so let's start by writing equations, and the first thing we should establish is, you see this is about bonds and mutual funds. Let's call X our bonds, and we'll call Y the funds, the mutual funds. Okay, so we need to spend at most $35 million in either bonds or mutual funds. So X plus Y, if we add those two things together, need to be at most, which means less than or equal to 35 million. Some people get confused by that. At most meaning less than, but remember at most means no higher than 35 or less than 35 million. Alright, we got to invest at least 5 million in bonds. Again, backwards thinking, at least is greater than, because when something's at least 5 million, it's 5 million or higher. And then same thing with mutual funds. Y, we want at least 10 million there. And then our final statement is going to be about the fees. Bonds have an initial fee of 100 per $1 million. So 100 and per is a fraction, right? 100 per 1 million is the amount of fees for the $1 million of how many millions of dollars of bonds we buy. Plus, and then it's 200 per million that we buy of mutual funds. So the same thing, 200 per, so we write a fraction of 1 million times Y, and we need that to be no more than 6,000, so less than or equal to 6,000. Now I'm going to simplify these fractions here into decimals. Let's see what they look like. So if you take 100 divided by 1 million, you get 0.0001. So I'm going to rewrite this as 0.0001 x. And hopefully you see the next one is just twice as much, so it's going to be 0.0002 y. You can check it with a calculator if you don't trust my math in my head, but that's what the number will be. Now, I want to get rid of these decimals. We don't really have to for this problem because I'm going to use graphing, but I think it's going to be helpful just to see the scope of these numbers. So I'm going to multiply both sides here by, let's see, 1, 2, 3, 4. A 1 with 4 zeros behind of it, or 10,000. Alright, because that's what that's going to do, is eliminate that decimal. So I'm going to multiply here by 10,000 and over here by 10,000. Alright, so to get the calculator back out, the 0.001, you see when I multiply that by 10,000, you'll see that just turns that into a 1. So that means this is just x plus, and then hopefully see again, this is just twice as much, so it's going to be 2y. Test me if you like on the calculator, but that's what it is. And then we have a 6, and then we have how many zeros? 4 plus 3 is 7 zeros. So $60 million. Alright, so we have our 4 equations here that are constraining us. And the thing we're trying to maximize here, we want to maximize the interest. And the interest is paid on bonds, 5% annual interest. So we write the function 0.05x, and that'll be our interest on our bonds, and our interest on our mutual funds is 0.08y. So now we have all the equations that we need to be able to solve this. So I'm going to go pull up Desmos.com graphing calculator. Let me show you what that's like. It's a really cool tool. Alright, so this is Desmos.com calculator. If you go to Desmos.com/calculators, you can see it's a graphing calculator. Now, some of you have a graphing calculator, and that's fine. You can use that as well. But I do actually think that this is a little bit easier to use than the graphing calculator, at least for creating these kinds of graphs. So what I'm going to do is I'm going to go get all of those functions that we just wrote down, and I'm going to graph them over here. So let's go back and get the first one. So our first one was x plus y less than or equal to 35 million. So I'm going to come over here and write x plus y less than or equal to 35 million. Okay, so what I did to get less than or equals to, by the way, is you put less than symbol using your keyboard, and then you can press the equals key on your keyboard and it'll do that. But also down here there's a button palette where you can get less than or equals to and square root and all these other things that may come up as you need. Now, if you look at our graph, it looks like a big red blob, and it's because it's shading the areas. So I'm going to zoom out. Now you can zoom like this. Now since we're zooming out to millions, it's going to take a lot of zooming out to get there. But if you keep zooming, you'll see that there's what the graph looks like. All right, now let me go back and get the other functions that we had. We had x greater than 5 million. All right, that's a really simple one. So we're going to come down here and do x greater than or equal to 5 million. And then we had y greater than or equal to 10 million. So y greater than or equal to 10 million. And then our final one was the one about the fees, x plus 2y less than or equal to 60 million. So x plus 2y less than or equal to 60 million. Now, what we have is we have all these areas overlapping, and you can see when they overlap like this, we end up having lots of colors, and it's kind of hard to tell where all 4 graphs overlap. I'm going to switch the colors. If you click and hold on that color, you can switch that to red. You can turn them on and off, by the way, by just clicking them once quickly, but if you click and hold, you can switch the colors. And same thing here, I'm going to switch the color to red. So now they're all red, and you can see the area that overlaps is this weird kind of quadrilateral shape that goes here to here, and then back up to here and here. So you can turn these all on and off one at a time, so you can see what's going on. There was the first one. There was the second one. So you can see already these two graphs overlap in this region here, and then these two constraints move the bottom kind of leg of this little 90-degree up. So we have this little shape here. All right. Now, one way you can even clarify this graph a little bit more is by adding domain restrictions here. You can say, look, we know that x has to be greater than or equal to 5 million. And what that does is it goes ahead and chops off that graph. This is kind of a unique problem that we can do this part on. And you see it takes that first graph, let me turn off the other graphs, into just that triangle, because we are limited that x has to be greater than 5 million and y has to be greater than 10 million. So it creates that little small triangle instead of all of that shaded area. And likewise, you can copy that same domain restriction down to this other function and turn it on. And likewise, x has to be greater than 5 million and y has to be greater than 10 million there. So when we turn both of them on, you can see the area that's bounded is right there. So now, to solve the problem, we're finally getting around to where we can get the numbers. We need to find out the intersection points. I'm going to take those back off. I'm trying to make it clear there about the area that overlaps. All right. So if you notice in Desmos, as you get to an intersection, it brings up a point. You can click that and it'll keep it on the screen. And then it intersects right there as well. And there's another intersection down here. And then there's another intersection. So those 4 points are the corners. And there's a corners theorem that we use that says the maximum for this function, the maximum will occur at one of those corners. So what I'm going to do is I'm going to come back over and I'm going to transcribe these points. So 5 times 10 to the 6, I'm going to rewrite that as 5 million because that's what that is. And this is 27.5 million. So I'm going to go back over and handwrite those, and then we're going to finally finish out the problem. All right, so I've copied over those values of those 4 points that were the corners of that overlapping region. So what you do now is you come over here and you take and do 5 million, and you're going to substitute that in here for x, and we're going to substitute 27.5 million in here for y, and we're going to see what that result is. Now at this point, I'm going to use the graphing calculator to demonstrate this. There's nothing really special about the graphing calculator for this. It's easier to type things like this, where I can go 0.05 parentheses, and then that was 5 million, and then we're going to add 0.08 parentheses, and then 27.5 million. And of course you could keep using that scientific notation we got from earlier. If you press equals, we get 2,450,000. So when we do that number for the first x and y possibility, so right here we get 2,450,000. Alright, I'm going to do that calculation again for the other three numbers, and I'll come back. So you can see I've run all those calculations now. I got 2.5 million for the second line of my table, and then I got 2.05 million, and then I got 1.05 million. So the maximum occurred where we got 2.5 million. So this one is our maximum solution right here. And that's why the correct answer is $10 million in bonds, 25 million in mutual funds, and the maximum annual interest here, that number will be that number we just calculated, $2,500,000.